Good morning, good afternoon, and good evening, everybody. My name is Frank Yu, and welcome to today's Bright Talk session with Kemp Technologies, how to simplify Kubernetes with load balancers. This is going to be a really cool and interesting conversation. We have special guests here, Barry Gleason and Roy Dunican. So first off, let me introduce. Just get a couple of housekeeping things out of the way. If you have any questions, this will hopefully be a very interactive session. Just click on the question mark and put in your questions. We're happy to answer any questions or clarify as we go through. This will be recorded and on demand on Bright Talk, and you're free to listen to this afterwards if you register for this event. So let's get started here. Again, my name is Frank Yu. I'm the Principal Application Experience Architect here at Kemp Technologies. And first off, we have Barry Gleason. Barry, give me a few words about yourself and what we're talking about today.
Oh, you've already put me on the spot, Frank. So I'm a product manager here at Kemp. I've been working with Kemp around 7 years. And one of my areas is around the Kemp Ingress Controller. So it's an area I'm very, very interested in as a product manager.
Awesome. And this Kemp Ingress Controller, this is something that we'll be talking about quite a bit, I think, in this conversation today, because it really ties into this concept of Kubernetes, and we'll be discussing that in 1 second and what it is and how it means. And again, we also have Roy Dunican. Roy, tell us a little bit about yourself and why you're excited about this conversation today.
Yeah, so I'm a platform ops team leader in Kemp. So I've been in Kemp for I'd say about 8 or 9 years now. So the reason that I'm interested in this is because I deal with kind of the platform and CI/CD and Kubernetes environments and things like that, and deploying microservices. So I'll hopefully give some insight here.
And that's, excuse me, and that's really cool because we aren't just building and creating these tools and saying, hey, here's this really interesting thing from our perspective for you to use. This is something that we're actually using and playing with and taking advantage of internally within our own organization. So I look forward to your insights with that, Roy. So let's get started. And I want to start by first, let's just kind of set the table straight in terms of what we're talking about. This concept of containers, microservices, virtualization, it's a really hot topic. Everybody's talking about it. And you have different container platforms like Docker, and you now have things like orchestration systems like Kubernetes. Why is this so popular? Why is it so hot in the IT world for the past few years? And what does it mean for us? Let's start with you, Barry. What do you have to say about this?
Yeah, so I was kind of thinking about this only recently. When we think of microservices and containers, the shift that it has brought to how we build and deliver applications is absolutely massive. And it actually, just thinking about that, it actually reminded me to earlier on in my career when you might have to build, I worked for a big telecom organization. You might have to build an application, and it involved putting in, ticket requests to IT that would actually have to create a physical. This is pre-virtual machine days. They'd actually have to deploy, a Linux machine for you. There would even be interdepartmental costs involved, things like that. And if you fast forward to today, only this week, I was creating an application through Docker, and you're literally talking about executing a Docker file and a couple of minutes later accessing this app that has been built in a container, maybe on your own Kubernetes environment or on your own node. And that's just a small example, but and Roy will probably give more insight in this, but when you apply this to how we deliver applications, how we want to segment applications, break up functionality, it's massive in terms of the changes.
Yeah, it is massive in the changes. And Roy and Barry was saying you could give us some insight. What has it done for you, and why are you doing this big shift towards this microservices, containers, and like you mentioned in your intro, CI/CD, continuous integration, continuous development type processes? What does this all mean for you?
Yeah, so like Barry kind of highlighted the dev aspect, and like I suppose as in like I cover that, but also the ops aspect, right? And it's like as in I suppose that's why there's a huge kind of industry around DevOps and things like that. And to Barry's point, it's like okay, you can spin things up quickly. It's like as in when VMs, okay, it was a bit longer. Like that's kind of the main differentiation for me. But it's also like we used to have an internal app that used to be failing quite regularly. Was running in a VM, probably wasn't resourced properly, but we had to do what Barry's saying, go through different people to get it resourced and fixed. But now, like by using kind of Kubernetes and microservices, we're able to deploy that. We can stage it, we can run tests before doing it, and it's like that's kind of the power. And we could actually release something in minutes, like as in regardless of actually going in maybe to a VM, running a script that would actually update the code in a safe manner. Like one of the other things it gives us is like repeatability. So if you, as Barry said with his Docker file, he's defining how the app should be built, right? So when he spins it up, it's going to be the same thing every time. But when you're messing with VMs and stuff like that, you might forget that one setting that stops like HTTPS from working, or it's like Nginx talking to your app or something like that. And it's
like how many of us have these Word docs full of
Yeah.
like copy paste commands so that we can replay it later on?
Yeah.
And then you miss one little piece, or you miss a firewall rule or an access control list or something.
Yeah, and like that's what it comes down to, and I think that's the real power from my aspect, because I suppose I have to run some of these internal apps, external apps, and I don't want to have to be woken up at 3:00 in the morning.
Oh yeah, absolutely. And this kind of leads into kind of my next thought here. So we have this system, this I'm going to call it ecosystem of technology and tools in terms of the microservices and the containers, and now the Kubernetes and what you're saying, this automated and scripting capabilities. How have things really changed now in terms of, and you've started touching on it, I have traditional applications, whether it's hardware, software, virtual machines, putting it on bare metal, whatever the case may be, and how I used to do in the old days, where if I wanted to build an application, I would order some servers, I would bring it in, I would order some software, I would install it, have people spend days configuring it and trying to replicate that, then creating this, as you kind of mentioned, Barry, you have this Word doc where you have this note. In the old days, in the telco world, we have what we call run books, right?
Yeah.
And these are literally 3-ring binders that you open that have the sequence of steps that you go through to make sure you do things exactly right every single time operationally. How is the Kubernetes world in terms of what it can do in terms of automating that and helping make things efficient, changing this world? How is the technology different with these microservices and Kubernetes versus what we have today? So I know there's a lot of technology pieces in terms of, we have these concepts of nodes and clusters and all these other different things and service IPs and stuff. Give me a good breakdown of what's new and what people need to focus on as we go into this world. So maybe Barry, I'm going to start with you again. What
Cool.
do you see as the major technology changes that
so just to pull it back a bit, because I mean, sometimes these conversations around Kubernetes and stuff, it can be a little bit overwhelming for people. To kind of put it in very simple layman's terms, if you think about the original applications, you would typically deploy a server, you'd put an app on it. I suppose the next step of that was virtual machines, where you could have maybe 1 or 2 servers that would run multiple virtual machines. Now, that was a big improvement. It made creating servers, whether they be virtual or real, much easier. But each virtual machine still had the overhead of having to have a full operating system on it. So if I wanted to deploy 3 Exchange servers, maybe 2 in production, 1 for testing, that was 3 versions of Windows Server that I had to run on 3 separate virtual machines, perhaps on 1 single piece of hardware. With containerization, this has brought this up another level, because what we've basically done is with containerization and the likes of Docker, we can literally have one runtime, and we can have all these containers that will just include the aspects of the operating system that container needs. So, I mean, this feeds very, very well into the concept of microservices. With a microservice, if you look at the word, it's just micro meaning small service. What you're basically saying is, if I can take my app and rather than having it one big massive thing, break it up into small services, this feeds perfectly into containers. Because what I can say is, if I have one service that maybe I mean, the typical example you might read about is if I have a shopping site and I have, for example, the shopping cart, I have the product page, I maybe have a product review section, maybe I have a product video and images. They're all different parts of that page. If we split them out into different services, what it means is we can upgrade them separately. If there's an issue with one, the application may be able to continue to work. So maybe my review section doesn't load, but the user can still navigate through the site, they can still access the cart and so on, rather than, you know, one big monolithic app that it's either kind of one thing failed and it causes this knock-on thing where everything else is down. So I'm probably going a little bit off topic, but in terms of the technology, by having the concept of containers and then using them to deliver applications via microservices, so splitting up your application, and then on top of that, Kubernetes is basically our way of managing these microservices. So it's all good, it's all well and good saying, "Oh, I'll break up my app," but if that means I have, you know, 30 or 40 different microservices to keep track of, that's not exactly easy. Kubernetes lets us orchestrate that, lets us do very fancy things like, you know, scaling up and down applications, lets us, as Roy mentioned, you know, have very strict configuration of how our application is delivered and so on. So that's kind of the technology aspect of it. Roy, you'll probably be able to give more more concrete examples, because I mean, how many microservices do you have? Do you manage?
Jeez, I don't know at this stage. It keeps growing, right?
That's what I'm thinking.
Yeah. And like, as in, like, it is all about that kind of orchestration layer, and it's like you're actually removing a lot of the manualness, and it will orchestrate how you need it to be, right? So I guess, and I mentioned it earlier about not getting up at 3 o'clock in the morning, but it's important because it's like, basically, if somebody else can push a button and restart the service without knowing anything about it, then you're, you know, that's part of the reason you choose this technology, is because, like, it does have its benefits over certain other technologies, you know. And it's like the main thing, and I suppose we'll talk about it a little bit, is it's all about the app, right? And it's all about delivering that and it being up, right? You know, like Barry alluded to it, that it's like, when things fail within an app, maybe the 90% of it still works, and that's what you want. You know, it's like you want that one little thing to fail, and the customer doesn't even notice that there's any impact. You know, but then, like, as in, when you come to say things like, if you've got a shop and it's Black Friday and you need to scale because, like, your demand is there, you know, you don't have to be building out loads of infrastructure that might take days. It could just be a matter of, like, say, minutes. Well, to put it in the evangelist terms, but it might take like a little bit longer than that. But I suppose that's what it comes down to.
Yeah, and that's really good insight. And if I can continue this question and extend it, Roy, and coming to you, Roy. You've been at Kemp, you mentioned, I think, 8 years. And so you've seen this shift from traditional to this microservices, containers, Kubernetes world. And you're like frontline in it and working with the. How has what you're doing changed with this? How has your, besides not having to wake up at 3 a.m, is this a good thing? What are you getting? What are you getting out of it? You know,
like, from my perspective, yeah, like, as in, it's definitely improved, I suppose, my life. Like, as in, like, our previous projects that I was working on, like, as in, I think we started it maybe, what was it, 2016, Barry? I think that's when
Yeah.
And like as in we shifted then to using containers and things like that, and I think we're using like Apache Mesos at the time, and as in that ended up not being fit for purpose, and we went to and started using Kubernetes. But like as in, I suppose I've been in that space now long enough where it's like I don't know any difference, if it makes sense, because I'm so used to it. But like as an example, I was at KubeCon this year, which is like a whole conference around Kubernetes, and like even the questions that were being asked last year versus this year, and even the software that accompanies like all this technology. Like it's not just you've got a VM anymore and you've remote syslogger, which or so you've got just you're sending something to a remote syslogger, and then you've got like some API commands that you're like monitoring and stuff like that. There's huge tools that actually like build out this ecosystem and actually try and give you either like the metrics you need for KPIs or even just day-to-day operation and kind of scaling or even reducing from a cost perspective and all those kind of things. And you can see more into your application now because when it was a VM, it's easier as well. So you got to remember that from a technology point of view, if you've got a real or like a VM or a physical host, it's a lot easier to understand what's going on and like traversing through a network, right? And there was a lot of tools out there for it, like SNMP and things like that to get what's actually happening. But now you have to build different tools that actually solve the same problems in this space. So there's even like new tracing tools coming out, and there's all these kind of, while the technology is getting better, it does add like a lot more complexity when you do get 2 feet in, and up to your waist.
And I think the other thing is a lot of these tools are kind of being developed and designed by the Roys of the world. They're made by the people who have to consume them. Now, that's really positive in one way because they're addressing the kind of real issues. But it can have a flip side as well. So it can kind of, how would I say it? It can scare off your guy who's maybe new to Kubernetes, who isn't used to these kind of tools. That's what I found myself. Even some of these things it can just be a little bit daunting.
Yeah, absolutely. There's a lot of moving pieces here. And like y'all said and alluded to, by breaking things up, it kind of gets more complicated. But then the Kubernetes piece is kind of designed, or the goal is to kind of bring it back together to bring that simplicity back into play to make things easier, right? So this is the challenge. And especially when we talk about this technology, and let's get into the meat of what we want to talk about today, is how do we incorporate these other technologies around this application infrastructure world of microservices and containers and Kubernetes, and specifically, for example, load balancing? Because load balancing, the thing about load balancing is we know, and for you listening, it's very tightly integrated into the application in terms of what it's doing, because it's acting as a reverse proxy. It can do content switching. It can do security for it can do all and does all these cool things in terms of managing the application on the network layer. So this changes in the Kubernetes world, right? Microservices blows apart the application into multiple little pieces. And I think we may have some visuals that might help explain, because now we have different, port numbers in terms of microservices being deployed and things like. How do we incorporate and integrate things like load balancing technology into this microservices Kubernetes world? Because this, I think, is going to be this is a very big and important question, because you have to get the entire ecosystem, like I said at the beginning, working properly and working together and playing nice. And I think at Kemp, we have some pretty cool things that y'all can explain for us in terms of what we do in terms of Kubernetes. And I'm going to go ahead and call out Ingress Controller and Service Controller concepts to help manage this from the load balancing and the overall application experience. So maybe I'll go back to you, Barry, because you played an integral role in terms of bringing this all together, and give me your explanation of what we're looking at here.
Yeah, so I think I preface this with certain things change massively, and then certain things kind of remain the same. So if you think about, I mean, we hear the terms monolithic application versus a microservice application. So kind of a very, I suppose, a simplified way of explaining what would be, with a monolithic application, the role of a load balancer would be to take incoming requests and basically distribute them across your servers. So you can see here on my monolithic app, I have 2 servers, I have requests coming in, and they get sent across them. With microservices, on the other hand, your application, rather than having 1 server versus 10 servers, will typically be spread across multiple nodes. And the microservices, or the application itself, will be broken up into a large number of microservices, which will be spread across these nodes as what are called pods. Okay, so in terms of the load balancer functionality, it will basically have to look at the request and decide where it needs to be sent. Now, you will hear the term Ingress Controller. An Ingress Controller is, just to kind of go back a couple of gears. So with Kubernetes, you have what's called a service definition. So what that means is you can define how a particular microservice can be accessed, or a particular deployment. So deployment could contain multiple containers. So when you're defining how that can be accessed, there's a couple of different mechanisms to do it. So you can use what's called cluster IP, which would be for any microservice that isn't really accessed from the outside world. It's typically just used by other services within the app. There's the concept of a node port, and what that means is every node in your across your Kubernetes will dedicate a specific port to that deployment or to that service, and that's typically 30,000 and upwards. So it might be 3001 or whatever the case may be. So they're just service types that Kubernetes have. We also have the concept of a load balancer service type in Kubernetes, which is typically used for cloud environments. And what that does is it's a way to indicate to the cloud provider that a cloud load balancer needs to be created for that specific service. That can work in a lot of deployments. It has its downsides in that if you're publishing lots of different services, you may need lots of different cloud load balancers, which can run up costs and so on. So what all that led to is this concept of an ingress controller. And an ingress controller is how we can define within Kubernetes how traffic coming into the system should be distributed across specific deployments. Now, I've probably gone a little bit off what I mentioned first, but all of that stuff is how they differ. Now, at the same time as that, a lot of stuff remains the same. So we still have this concept that's very common with load balancers and reverse proxies, which is offloading your TLS and SSL. So in other words, having an endpoint that takes your connections, that implements cert management, does the decryption, and front ends that away from your services. So I remember a colleague of mine once said to me, and this is quite a long time ago, he said, let servers be servers. So in a lot of cases, when you're designing applications, it makes a lot of sense to let your applications and your servers perform their functionality, and let other devices perform other functionalities. So that could be TLS SSL offloading. It could be your WAF, your web application firewall. It could be anything to do with access management to your application, caching and compression, rate limiting. So all of these things, they actually remain the same when it comes to microservices. They are all things we still have to think about and worry about. So I suppose my point is some things are different, but there's some things that actually do remain the same.
Awesome. That makes a lot of sense. And then integrating that load master, load balancer technology into the microservices world starts making a little more sense, at least to me, and bringing it all together. Roy, what is your perspective? How is this driving what you do? How much have you incorporated? I'm assuming and hoping you've incorporated a lot of what we do with the load balancing technology into your day-to-day work and everything that you're doing. How does this impact you, and what do you take advantage of? What are the great things that you're taking advantage of in terms of how the load balancer integrates into this?
Yeah, so like I think Barry kind of mentioned something about me earlier, and it's like I'm not sure if it's quite accurate, but more being like the developer side of things, and it's like that perception of like things are done. And I think from my perspective, like the Kubernetes aspect is very much like it's dev driven, it's people trying to solve a problem, and but it's coming from maybe the wrong viewpoints. Like, so I suppose to back up, I suppose Barry's sides is in, we all know, because we're in the space of load balancing, that it's not just about kind of trying to solve something like SSL or TLS. Like, there's definitely multiple protocols out there you can do and you can incorporate. But there's like, I suppose there's other aspects from what a customer may need that a developer mightn't think of. It's like, I suppose that's why there's that PM function, right, to translate the customer requirements into technical stuff so that it can get done, right? Because I suppose, like, it's just, we can think about it in one way, but it's like you are going to get kind of, I suppose, either shoehorned or make compromises about how you, like, say, deliver your app if you were to like stay in that ecospace just by itself, right? And as an example, like I was trying to use the inbuilt Ingress controllers. I'd migrated and I'd used a few of them, and like they work for dev and things like that. But maybe like my ops hat is a bit different, where it's like, well, how do I know I can get the reliability, that I need? And it's like, if it is a thing that, Kubernetes is this awesome thing and it works all the time, it's like, I suppose we'd be lying, because it's like, it's a system at the end of the day. Systems fail for whatever reason. It doesn't matter. It just, they have their own moods. And, the more abstraction you can take out of that, and the more kind of, I suppose, having something outside and trying to deliver your app in a different way might actually like bring it up and give you more resiliency and things like that. So I suppose that's why I incorporated the load master and things into our architecture. Not just because I had previous experience with it, but it's like there was an actual like technical lead and like an operational need that I needed. So then I just had to ask the company to build something for me, right? So
So this is a good point I want to drive into. You asked the company to build you something, and here I'm kind of thinking and talking about this Kemp Ingress controller. And the Kemp Ingress controller, you talked about, Roy, about using the built-in or other Ingress controllers, which I'm assuming one's built into the containerized microservices infrastructure or third party through Kubernetes. Tell me and tell the audience exactly what is this Ingress controller? What does it do, and why is it so important in terms of incorporating and tying together the load balancer into this Kubernetes environment?
So like, as in, I suppose it's the pivotal point. It's like, why do we have load balancers in front of like real or physical hosts or VMs? It's the same problem you're trying to solve. You're either trying to do SSL offloading, you're trying to, like, as in, you don't know where the app is. Like, so Barry alluded to it in his diagram. It's like, if you've got 10 hosts and your app is moving between them and you don't know where it's going, then how do you make sure you deliver that? So that's what the Ingress controller, even just the inbuilt one, is trying to solve. Trying to make sure that your app is consistent. I suppose that's why we use virtual service IP, because it's a logical IP that you can go and you always know that will change. But if you decide to even move your VMs to a different cluster, the IP could change, but you still don't have to change the rest of your infrastructure. So at its core, it's still the same. And I suppose like from our side is like as in then it's like you still need to do the same things, right? It's like, okay, we're outside the cluster, but we still need to find out where the pods are. We need to listen. We need to find out when they move, when they orchestrate, because as soon as your real server goes down, it's like it's potential revenue loss depending on what it is, right? So, yeah, I don't know what else to say about them, but Barry, do you have anything else you want to add?
Yeah. Like I mean, the way Kemp has implemented the Ingress controller, we basically support an Ingress controller running on the load master outside of the Kubernetes cluster. So what this means is we can actually accept traffic for both microservice applications, but also your traditional monolithic applications. So if you look at this diagram here, if you look at the right-hand side, what's labeled monolithic, this would be kind of your traditional load balancing. So people familiar with Kemp and with load balancing will have heard the concept of a virtual service or a virtual server, which is basically an endpoint that you're going to distribute traffic. Traffic that arrives to that endpoint will be distributed across your application servers, whether that be 2 or 10, depending on how you have it configured. Now, with the Ingress controller, what in a way, a lot of it is similar. So what an ingress resource is in Kubernetes is a way of defining how traffic should be handled into Kubernetes. So this is a definition, as Roy alluded to, it can be controlled and so on. And it's a way of declaring, hey, traffic with this URL or with this path needs to go to this particular service, which could be a number of pods, or it could be one pod, depending on how you've scaled it. So with the Ingress controller on Loadmaster, what we basically do is we use the Kubernetes API to automate the provisioning of those virtual services. So you could imagine where on the right-hand side, the monolithic application is statically configured. Maybe the developers put in a request for a new service, or maybe it's been pre-planned, whatever the case may be. A virtual service is created. We know that endpoint is going to that app. With the Ingress controller, we have an Ingress resource that is going to have within it defined paths and defined behavior of traffic coming into Kubernetes. And what the Kemp Ingress controller does is it basically reads that and facilitates it and makes sure that it happens. So it's almost like a way of automating the building of the virtual service based on the Ingress resource. And from that point on, a lot of the rest of it is actually no different than how load balancers, reverse proxies, application delivery controllers, whatever you want to call them, have been doing for quite a long time. They've been taking traffic, they've been doing smart things like I mentioned earlier, WAF, TLS, or SSL offloading, caching, access management. They've been doing the routing of traffic based on paths and so on. So the functionality is very similar. Where the differences arise is maybe we're on the right-hand side. These are very static. You've 2 real servers. Maybe on Black Friday you add a couple to deal with demand, whatever the case may be. On the left-hand side, what are in effect real servers now are containers. These containers may scale up, may scale down very frequently. The other aspect of this we didn't mention is with Kubernetes manages container state. So if a container crashes or fails, Kubernetes is going to kill it and rebuild a new one. So from a kind of load balancing perspective, what that means is your real server in effect has gone down and a new real server has been added. But by us actually performing the Ingress controller role, we can automate all that. So, Roy alluded to the 3 a.m. call. If that pod fails, Kubernetes spins up a new one. It has a new IP. But because we have the ingress defined, we've defined how it should behave, our virtual service dealing with that is basically going to react and it's going to add the endpoint as needed to that new pod. And we don't get any 3 o'clock call. Everything stays up and resumes functionality.
Like one thing I'd like to add as well to that diagram, sorry, Barry,
yeah,
is that basically you see both Kubernetes and the monolith, if you're calling it that, but it's like more of the traditional environments sitting side by side. And like that was another benefit for me is having that ability to support both, because in the perfect world I would use Kubernetes 100%. But some apps either need to be more performant and can't rely on the like shared resources, or they just need like the huge amount of CPU, or it's DBs and DBs need to sit outside, and it's like you need to manage, the reality is you need to manage both.
Yeah.
And that's the other benefit of, I suppose, is like us having the Ingress mode or the Ingress controller outside of these environments.
Yeah, I think it's an aspect that has been kind of, I won't say ignored, but maybe not addressed as much, is that not every organization has your kind of your DevOps structure, whereby the same people are building apps and also looking after networking and how traffic comes into it. I think the hybrid delivery of applications with both monolithic and microservices is something that everyone should consider, because there's always going to be, in an ideal world, yeah, we rip down every application, we rebuild them all as microservices. In reality, I don't think that's going to happen. You're always going to have your monolithic applications you're going to need to manage. And I think that's a consideration for anyone moving to microservices. Another aspect that is also actually supported on Loadmaster is an even more integrated hybrid model, where you can potentially have a single endpoint that sends some traffic to microservices, and that's all automated, but then sends other traffic to monolithic applications that's much more static. And that's also a configuration that we support.
So that's all really cool information. And I think one point I understand, I believe I understand, to clarify, is that one of the challenges with this microservices containerized world is that when Kubernetes decides that we need another instance of this microservice piece of an application, Kubernetes decides where it goes in terms of what node or what cluster or what IP, where it goes within the entire microservice containerized environment. And then the port that's assigned, because we traditionally think of, okay, I'm going to be running on a web server, so I'm going to be running TCP port 80, listening on TCP port 80, or if it's SSL TLS, I'm going to be listening on TCP port 443. And so from a load balancing and from a client application perspective, it's very obvious that I need to go and load balance this port on this IP address. In the microservices world, that kind of goes away because it's all now dynamic. You said earlier, Barry, that it's going to use high port numbers, 30,000 plus, and we don't know exactly which IP. So that Ingress controller becomes critical then to extract that information from the Kubernetes system to know what IPs, what ports and things, and which microservice is being assigned to applications to make sure that it gets applied to the load balancer configuration appropriately. Is that correct?
Yeah, so like the node port concept, while possible to be used, isn't, as you mentioned, isn't that practical, because for users having to know high-end ports to access specific apps. So it can be used when you're building stuff, but yeah, typically you will have either a cloud load balancer, which is this concept that your cloud actually spins up a dedicated machine on a per service basis. Not very scalable, but if someone's getting started, it is a pretty quick way of to get something up and running and using a port. So Ingress controller would be typically used. Now, where a lot of Ingress controllers differ is a lot of Ingress controllers are containerized themselves. So what that means is you actually still have to manage the load balancing of traffic, because at the end of the day, it has to go to one of the nodes. And what the Ingress controller will typically do is kind of have its own node port, if that makes sense, on a well-known port. So let's say the Ingress can accept traffic on, say, port 443 or port 80, and then because it's within the Kubernetes, it will then distribute traffic across to the pods. So this is actually what a lot of people end up with when they're first looking at this. So what you would have is, in this case, I have 3 Kubernetes nodes. And what I have is in this case, this is a containerized Ingress controller. And what that containerized ingress controller is going to do is take the traffic from, it's going to come in one of the 3 nodes. It's going to hit that ingress controller, which is going to look at, in this case, the path, and then decide which container to send the traffic to. Now, what tends to happen is people then end up having to have some way of actually distributing the traffic across those nodes, and typically end up with an external load balancer. And in some cases, then you kind of can end up going down the path of a kind of a double load balancing, because in effect, the first load balancer is really just distributing it across the Kubernetes nodes, and then the second kind of load balancing is what's performed by the ingress controller to actually get it to the pods. So there are specific external load balancers that you can have containerized kind of endpoints that get them to react. We've done it a different way, where we're actually just taking that ingress function and performing it outside of Kubernetes altogether. And that, as I said, gives the advantages of, an easier transition, and it allows for a hybrid, and even allows for a kind of combined delivery of applications through both monolithic and microservices.
So that's awesome. So you're telling me basically what we're taking that built-in Ingress controller capability there and bringing it and tying it more directly to the external load balancer by using, for example, the Kemp Ingress controller functionality. And it makes it much easier, and I'm going to use marketing words here, much more seamless and transparent in terms of managing this infrastructure, right? And making it easier for you, because as we know, and Roy, you can tell us firsthand, this microservices environment is much more dynamic, like has been mentioned a couple of times, than this monolithic world where things are changing on a regular basis. So lots of different stuff going on here, and it's important to have that system that can understand these dynamic changes and incorporate them directly. So has this been your experience, Roy, in terms of how you've been able to take advantage and get the benefits out of Ingress controller and load balancing in your environments?
Yeah, like I suppose it's like just at the current project we're working on, I would say there's a check-in every 15 minutes, which triggers a new pod. So it's a new service, and then because
you don't want to have to contact your network operator and get them to update the real server.
No, that could be just one service, right? Because there could be multiple people working on it. It's like, so it's kind of like it's I couldn't even imagine having to do that. But I suppose one of the key points for us is is the different kind of, I don't know if Barry, you mentioned it, but the different modes and things like that around the Kemp Ingress controller, because that for me has different ways of doing things, right? It's it's I know they're using terms within Kubernetes, but for me it's one is kind of the service I kind of consider as being more stable, more production grade, things like that. While Ingress is that bit more of it's either that dev element or it's kind of kind of used for our staging environments and stuff like that. And we found great value of being able to do it, because as in on one hand we have to support the dev guys, and because not every organization has not every organization is built in such a way where everybody's DevOps, as Barry said, as in there's sometimes teams that do it, sometimes it's somebody's part role that does it, and it's if you end up as in where there's split responsibilities, then you need to make sure a dev person, when if you're a DevOps engineer, it's when's that point of you kind of cut off and you're no longer on call, or in charge of the production environment, that it if it goes down it needs to be fixed, or who takes care of the enterprise grade platform, if you want to call it that, as in where it's it's always up, it's always running, it's all automated, so that you don't have to worry about it. But then you also need this other space over here where you're kind of playing around with things. So Joe, there's a lot of hats to wear, and it's about deciding which hats to do it. And it's like, I think that's what the two modes kind of represent for me. Like, service for me is like, I can go in, I can set things. I know they're going to be very stable, like a normal load balancer, or like in the past where like with more traditional loads where it's like the virtual service will stay the same, my endpoints will stay the same, but only the pods get updated when I actually release, you know. And it's like, I have that, I've reduced my risk now because I know that there's less things that'll change. But with an ingress mode, like as in either we can code it inside in Kubernetes where like destroy everything, and like as in rebuild it from scratch if it changes, or like as in we can actually like check all that kind of stuff into say our Git repos where we can actually make changes in Git and like push it out that way. So just kind of really three kind of really kind of cool use cases there, and I think for me that's why it gives the best operational value.
Yeah, like to put some context around that, one of the challenges we identified with customers was those looking to adopt Kubernetes. What you ended up with is kind of this almost gray area where you for DevOps teams, maybe it's fine, but in a lot of traditional organizations, you could have two separate teams. One that's more network operations, dealing with devices and dealing with, network endpoints, published IPs, SSL offloading, certificate management. And then you might have another team that are actually in charge of making sure applications are available and doing upgrades and apps and so on. The ingress concept, and we've kind of alluded to it throughout the discussion, kind of sits in both areas, because what you're talking about is how specific traffic is routed and what application it goes to and things like that. And that can be a challenge for these kind of organizations. So what we actually implemented was a kind of a unique mode on Kemp for these kind of structured teams, and we call it service mode. And not to get into the nitty-gritty too much, but basically what it allows a network operator do is assign a specific VS or a specific ID to your development team, and then they can work away with that. They can add paths, they can remove paths, they can scale up, they can scale down, and that network operator doesn't really have to worry too much. But at the same time, because we're implementing the Ingress controller to a kind of a strict, confined kind of way, the RSs and stuff will still adapt in the manner that I explained earlier. So when pods scale up, when pods scale down, the VS will react. But maybe I don't want to give the development team full kind of access to be able to create 100 VSs when they want and delete 100 VSs when you want. So it just gives that level of control that what we've seen a lot of organizations need.
Frank, I think you're muted.
I think you're muted there, Frank.
I sure was. I apologize. I wanted to make sure that you got all the good information from you, Barry. So as we tie this up, I'm going to put you on the spot, Barry, and I'm going to ask you a question here. And we talk about how we have these environments where we have microservices, we have monolithic. And honestly, from my perspective and talking to customers and people and seeing things, is, you said it, Barry, people aren't going 100% containerized world. Not everything is not microservices. But then again, they are doing some migrations and updates and moving into this world. So it's hybrid. They have both, and it may be part of the same application, maybe different applications. Some are containerized, some are not. And of course, at least I say, of course, we still need load balancing for all of these applications. Load balancing technology is still important for the availability, scalability, security, and all those other good things. What is your recommendation, Barry, for businesses and people that are looking at these or moving into these hybrid environments with containers, and to integrate and make sure that they leverage their load balancing technologies and don't hit any major issues as they do this transition?
Yeah, I would definitely recommend just considering what that path looks like, it's fine saying, oh yeah, we're moving to microservices by, I don't know, 2025, and that's the end point. But just consider how you're going to get there. You know, for all the good of microservices, it's not a magic wand that's going to fix everything, and you're always going to have challenges. You're always going to have, you know, I suppose app-specific things that need to be considered. I would definitely recommend that people accept that monolithic applications are going to be around for a long time, and just consider that when planning. And maybe look at the services that they typically use through monolithic applications, and think about, you know, how are they going to be implemented when they move to microservices? Because, you know, as I mentioned, things like security, things like access management, WAF, and so on, that stuff doesn't go away. In fact, you could say it's even more crucial, and that all has to be part of the discussion, part of the thinking.
Yeah, that's great insight. Absolutely. It's not going away. So how do you incorporate and manage these pieces together and go through that process? That's a great insight, Barry. And for you, Roy, I'm going to turn this a question around for you, because you have a lot of practical experience and you've been dealing with this from the beginnings or early on in this technology process. What should any network operator or DevOps person or people dealing with this technology and dealing with ingress controllers and load balancers and these microservices, what do they need to make sure they avoid doing so they don't screw things up? What are the big gotchas that they should worry about?
That's you. When do you want me to wrap this up?
Can we extend it an hour?
I'm just even trying to think. It's like I suppose like when Barry was talking, like is in like that was kind of some of the things that I was thinking about. It's like, well, how did, like, you know, your performance of your app, like, do you need caching? Do you need a certain amount of throughput, TPS? What's the SSL version? You know, a number of like connections you can have per second, basically. Like, as in, what do you expect? You know, as in, can these apps, can these infrastructure kind of support that? You know, it's like you definitely need to think about like, yeah, do I need access management? Like, as in, are these the things that say my customers need? You know, because it's like, at the end of the day, these are all apps. They're all like, as in, they all need to be like serviced in the right way. You know, you want to remove the entry point into your application, and you don't want to have like people to get there, right? It's like you want to either have your ESP with your SSO at the front, so you don't have to do it on your app, and you want that off your system. You know, you have the WAF to try to stop blocking people get in. You know, whatever it consists of, like these these things just don't go away, and you really have to consider that. And then from the infrastructure point of view, it's like, and Barry kind of said it as well, it's like it's nearly like just little by little. It's continuous improvement, it's continuous kind of changing, and it's like you got to take it on an app per app basis, because like I couldn't even dream if you put like, as in, I had to like change everything to microservice by 2025, I'd have a heart attack. You know, it's like, Joe, because you just don't know in that time frame. Like, I could tell you what I could do in 6 months, like, you know, in like with some certainty. But what about like in a year's time when there's a new app that requires different parameters? Like I mentioned it earlier, it's like, you still need those systems that have like dedicated apps, like whether it's a DB, because like that DB or your app runs Java, and okay, Java isn't, can be a bit memory intensive, and it's like, what if, like, I don't know, as an example, Cassandra needs about 6 gigs of RAM to operate. You know, it's like you couldn't try and jam that into these architectures, because it just wouldn't suit. But you could run a dev environment, and you could, enable your life that way, so that it's like you could spin those up and things like that. So it's about really looking at whether like the different stages you need, like dev, stage, maybe production, and going, what suits me for that particular thing. And I suppose that's why the modes are important as well, because, as I said, service mode might be used for somebody who's very wants to take the risk away from your app going down, and they want it all very structured and like nearly written in stone. But ingress mode can be done, quite dynamically, and it's literally just down to those kind of points.
Awesome. So it's important, if I can distill some of what you're saying, and my personal takeaway is that even though we're tearing apart this app into microservices and things like that, it's still an application. And all the functions that we traditionally applied to this application, like Barry and you've mentioned, like the TLS SSL security, like the web application firewall, or external authentication, single sign, whatever the case may be, still apply because it's still an application. We're changing how it looks on the back end, but ultimately at the load balancer and on the front end, we still need to make sure that we apply the same technologies and the same concepts and functionality. And as you were saying, Barry, it's a hybrid world. We're moving where we need to make sure we can integrate and tie. The monolithic stuff is not going away anytime soon. I mean, we still have mainframe computers out there that were built in the 1960s running in businesses, right? So the stuff's not going away. And we're not going to convert 100%. So it's a matter of making sure we tie things together and bring it all together in a useful way. And for me, the load balancer, again, is a critical point, because it's the bottleneck. All the connections go through the load balancer into these applications, whether they're monolithic or whether they're spread out into these microservices. And tying all these things and tying in through this Ingress controller and service controller models and things into the microservices world, it makes things easier. Ultimately, it makes things even though it seems more complicated, by breaking out and having a lot more pieces to deal with. From what you're saying, Barry, and what you're saying, Roy, is it makes things ultimately easier. It makes things that you don't have to wake up at 3 o'clock in the morning to fix or change things, and it's a good thing for us to look at and incorporate into our IT architectures. That's my takeaway. That's my personal takeaway. Hopefully y'all kind of see that assessment, and if not, definitely chime in here for any last minute comments here, and hopefully everybody else is seeing similar things. So I appreciate everything that you have shared with me, Barry and Roy. This has been extremely insightful, especially for me personally, and hopefully for the audience listening to this webinar presentation. And hopefully we'll see you on more Kemp presentations and webinars in the future on Bright Talk and other channels. Please follow us and find us, and we'll be happy to share more things in the future. We look forward to talking to you real soon. Thank you, everybody. Bye.
Thanks, Frank.
Bye.
See you guys.